All right, the next thing that we are going to go over is compound probability. All right, so on Wednesday, you guys watched a video on just finding regular probability with one event. Now we're going to be throwing in two or more events. Most likely it's just two. All right, so compound events is when we combine two or more events using the words and or the word or. Okay, so we're either going to have and statements or statements. If we have an and statement, we're either going to choose if it's independent or dependent. These two are important because they have different formulas. Okay, same thing for or statements. In your statement, if you have an or, it's either going to be mutually exclusive or it's going to be overlapping. And we'll talk about the definitions in a second. All right, with independent versus dependent, these are your and statements. So whatever you're trying to find the probability of, it will have and in your question. If it is an independent event, the occurrence of one event has no effect on the occurrence of the other. So they're two totally different independent things happening. Okay, so if they have no effect on each other, you're going to multiply them. Okay, so the probability of the first event happening times the probability of the second event happening. Dependent events, the occurrence of one event affects the occurrence of the other. So if probability A happens, it will affect probability B. So you're still going to multiply, but you're going to multiply probability A times the probability that B happens given that A has happened. Okay, so you're finding the probability of B assuming that A has already happened. Okay, so this is just stating right here. So this is probability of B given A. This is assuming that B is going to happen. So you're finding the probability of B that A already happened and that it is true. Okay, we'll go through some examples right now. All right, so a quality inspector of a car manufacturer randomly selects one car from each, this should be each bank, of 50 cars to inspect problems for, okay? So an inspector has two different sets of cars. Should be batch actually, okay? So he's gonna look at the first batch of 50 cars. In that first batch, he has 4 that have sticky gas pedals. Okay, so it sticks. It's not really smooth to push down. The second batch of 50 cars has 5 cars that have the same problem. So first batch of 50, 4 cars have the sticky gas pedals. Second batch of 50, 5 of them have that same problem. Find the probability that the inspector will select a car with a sticky gas pedal in the first batch and the second batch. So things I want you to recognize. Now this will not be given to you. You will only be given the word problem. I'm giving it for you so that way you can see. Okay, so some things you have to recognize are, it's an and statement. So and statements means that we're going to multiply. The second thing we have to look at is whether it's dependent or independent. So going back to second slide here, and statements are independent or dependent, okay? Now, remember, independent means they have nothing to do with each other. Dependent means the first one will affect the second one, okay? So let's see, you have the first batch of 50 and then the second batch of 50. Now these are going to be independent because when I pick from the first batch, that's not going to affect the probability in the second batch because they're two totally different batches of 50 cars, okay? So I'm going to do probability of A times probability of B. So the probability of me choosing a sticky gas pedal car in the first batch is 4 sticky gas pedals out of a total 50 times the probability of B, which was the second batch of picking the same sticky gas pedals. So there was 5 of them over 50. That gives you 20 over 2,500. Simplify that fractions to 1 over 25. That gives you this. Now, this is telling you right here, kind of like what we talked about yesterday or Wednesday in the PowerPoint and in the video, this is very unlikely to happen. Okay, because the closer it is to 0, the more unlikely it is to happen. The closer to 1, it's more likely to happen. But that is your probability. Okay, Next example, we have an aquarium contains 6 male goldfish and 4 female goldfish. You randomly select a fish from the tank, do not replace it, and then randomly select a second fish. What is the probability that the first fish is a male and the second fish is also a male? Now, things I want you to recognize. It is also an and statement right here. And means we are going to multiply, and also means that we have to choose whether it's dependent or independent, okay? This is dependent because when I take a fish out of that fish bowl, it changes the probability of me picking that second one because I'm not replacing it. If I were to put it back, it would be independent, okay? So because I do not replace that fish, it is dependent, all right? So I have to do the probability of male and male. So my first probability A, there's 6 male over a total 10 fish times, now I am assuming, so if you go back to the formula, probability of A times probability of B given that A is true. So I'm assuming that there is not 10 fish in the tank anymore, there is 9, okay? I am assuming that one of the males was chosen, so therefore there's only 5 left, okay? So that's what that means when you are talking about given statements, okay? Multiply across, 30 over 90 simplifies to 1/3. You have this probability of 0.33. Now this is more likely to happen than the last one because it is closer to 1, okay? So those are the difference between independent and dependent, okay? For and statements, all right? Now let's go over some or statements. So we just went over and, these are or, okay? Or statements can either be mutually exclusive or overlapping, okay? Mutually exclusive means that they have no common outcomes and the two things can't both be true at the same time, so they cannot happen at the same time, okay? If they are mutually exclusive and they cannot happen at the same time and it's an or statement, you're going to add them together. So the probability of A happening plus the probability of B happening, okay? Overlapping, this means they have a type of common outcome, so two things that can happen at the same time, okay? You're going to do probability of A plus probability of B minus probability of A and B. So an example I can give you real quick. So mutually exclusive events, an example of this would be, so I'll put another example in here. So example could be picking a queen and picking an ace, okay? So from a deck of cards, they do aces and queen, or queen and ace, they cannot happen at the same time. So if I pick up a queen, it can't also be an ace, okay? An example of overlapping could be picking a queen or picking, it should be or. Okay, so picking a queen or picking a club, okay? So if I pick up a card, it could be a queen or it could be a club, but it could be a queen of clubs. So that's overlapping there, so that you would have to subtract that here, okay? So you could say picking a queen, picking a club, minus picking a queen that is a club, okay? All right. So kind of like what we just talked about. What is the probability that you choose a queen or an ace? So this is an or statement, so we have to add. It is mutually exclusive because you cannot pick a single card and it be a queen and ace at the same time. Okay, so that's like what I was just talking about here. All right, so the probability of picking a queen or an ace, so probability of queen plus probability of ace. So the probability of me picking a queen, there's 4 queens in a deck, so 4 divided by 52. Plus probability of picking an ace is 4 over 52. They have the same denominator, so leave them and then add your numerators. You can simplify, you can take out a 4 from each, and then you can get put it in your calculator and you get 0.15 as your probability. Okay, so that would be mutually exclusive. You cannot pick up a card and it be a queen and an ace. Okay, next one. what is the probability that you choose a king or a club? Okay, so this is again kind of like what I talked about in the last slide. So things you need to recognize. You have an or statement, so you know you're going to add and you're going to subtract because they have overlapping. Okay, so it is overlapping. It's not independent, or it's not mutually exclusive, because you can pick a king, or you can pick a club, or you can pick a king of clubs. Okay, so I rewrote my equation here. So probability of king plus club minus king and club. So probability of king is here. So 4 kings out of a total of 52 cards, plus there are 13 clubs out of 52 cards, minus there is a king of clubs. There's one of them. Okay, so I'm just going to, all the same denominators, combine like terms on the top. So 4 plus 13 is 17. 17 minus 1 is 16. I'm going to take out a 4 from each and get 4 over 13. And then you have 0.31 as your probability. Okay, so a little bit of notes, kind of quick, a little bit of an overview. You're either going to have and or statements. With your and, you either have to choose independent or dependent, follow the formulas, or you're going to have an or statement and you're going to pick whether it's mutually exclusive or overlapping and choose one of those formulas.